Hello everyone. Welcome back to Dr. Lu's VCE Physics channel. Today, let's learn together about the 2022 NHT Physics examination. We will focus on questions related to light as a particle. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. If the intensity is increased, then the number of photons hitting the metal will increase, leading to more photoelectrons. So, B and D are eliminated. Since the frequency of the photons has not changed, their energy has not changed, and as a result, the maximum kinetic energy of the photoelectrons will remain unchanged. So, C is eliminated and A is correct. The gap between lines are 0.7, 1.9, and 10.2 electron volts, so B is correct. The word laser is an acronym for light amplification by stimulated emission of radiation. So, B is correct. Matter particles have de Broglie wavelengths related to their momentum. So, C is correct. The inability to simultaneously know Heisenberg's uncertainty principle describes a particle's position and momentum. So, D is correct. This apparatus is used to study the photoelectric effect. Light of various frequencies and intensities can be shown onto the metal plate to produce photoelectrons. The voltage of the power supply can be varied and the direction can be reversed. Compare experiments B and A. Identify the intensity and frequency of the light in B that needs to be changed so that B gives the same results as A. The photocurrent of B is the same as that of A, so B's intensity should remain. However, the stop voltage of B is half of A, so the frequency of B should be double if they have the same magnitude of stop voltage. Compare experiments B and C. Identify the intensity and frequency of the light in B that needs to be changed so that B gives the same results as C. The photocurrent of B is double that of C, so the intensity of B should be halved if they have the same magnitude of photocurrent. However, both B and C have the same stop voltage, so the frequency of B is not changed. First, we calculate the energy of a 700 nanometers photo. Then, compare this value with the work function. If its energy is above the work function, the photoelectrons will be ejected. However, the value of energy is less than the work function, so no photoelectrons is ejected. Applying Planck's equation, we calculate the wavelength of X-ray. Please use eV as the units of Planck's constant, and convert the meter into nm. Since the electrons produce the same diffraction pattern as the X-ray, the wavelength of electrons is equal to that of X-ray. Applying de Broglie's matter wave equation, we calculate the speed of electrons. The units of Planck's constant is joule-second, and units of wavelength are meters. Photons with energies matching the transition energies between shells will be absorbed as the electrons are excited to higher energy states. These photons are missing from the spectrum. Electron diffraction. Classical physics predicts that electrons passing through a tiny aperture would continue to travel in straight lines. However, these electrons are observed to diffract according to their wave property. The electrons jump down from level 4 to the ground. This jumping releases photons with 3.61 electron volts. The wavelength of light is calculated with Planck's equation. Please note that the units of Planck's constant is eV. Electrons exhibit a wave property. Only orbits with circumferences that are a whole multiple of this wavelength will permit a standing wave to form. In light as a particle, 5 multiple-choice questions are worth 5 marks, and 5 short-answer questions are worth 21 marks. The overall score for this section is 26 marks. With a total possible score of 130 points, the percentage for this section is 20.0% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.